Hey guys, this is your tutorial for Thursday, April 15th. Make sure you do today's activity so that we can give you credit for attending school today. Couple of reminders, we have our Force of Motion vocab that's due on the 22nd, that's Thursday. So make sure you're wrapping that up and getting that ready to turn in. Also today in class we did some motion graph practices where we looked at a motion graph and kind of analyzed the motion that was happening at each segment. And it kind of looks like this. So this is found under your classwork tab. It's titled Motion Graph Practice. If you will, go ahead and get that out. I'm going to briefly go over the activity and do a couple of them with you just to get you started and just to really show you how it works. Okay? So for this activity, it looks like this. It says motion graph practice. Has this motion graph here, which it shows the speed of a moving object, and it's the distance traveled over time. So you see your distance on the Y and your time on the X. Okay, so it's like in every second versus every 10 meters. Okay, so distance and time. It says use the graph on the next two slides to answer the questions beneath them. For each segment of the graph, you will then label the type of motion that's taking place. So is it accelerating? Is it constant speed? And there's actually a word bank for you to drag and drop and use that's found on slide 6. After that, there's one more slide to do that shows you a graph of a race, and you just have to analyze that graph and answer the questions. So the first part shows you this distance versus time graph, and it shows you what's happening between different segments. So A to B, B to C, C to D, D to E, and E to F. So the first question says, between which two letters is the rate of speed the fastest? So we know to calculate speed, it's distance divided by time. You could sit here and take the total distance gone and divide it by the time. So you could say, okay, that went 10 meters in 5 seconds. So 10 divided by 5 is 2 meters per second. So I know this object traveled 2 meters per second in this segment. But what we know about slope and the way a line looks is the steeper the line, the faster the object's going, right? So the steepest line we see on this graph is B to C. So from B to C, that object went a total of 10, 20, 30. It went 30 meters, and it only took it 5 seconds to go that much. So 30 divided by 5 is 6 meters per second. So that definitely went a lot faster. You can tell that this line is much steeper than the other lines. So for number 1, the line segment it's definitely looking for is B to C. So I'm going to write B to C. The next question says, the least amount of distance covered happens where? So from A to B, I went 10 meters. B to C, I went 10, 20, 30 meters. C to D, I went 10 meters. D to E, I didn't go anywhere. I stayed in the same spot. And then E to F, I went 5 meters. So from D to E is where I saw that I really didn't go any more distance at all. The object was not moving. So the correct answer would be D to E. And then what is happening between C and D, and how do you know this? So looking at the graph, we have C and D here. So anytime we see a curve, like from A to B here, whether the curve goes up or the curve starts to flatten, anytime we see a curve, it's a form of acceleration. So it could be positive acceleration and speeding up, like we see here in A to B. The object started out kind of slow and then sped up. Or you can have the opposite reaction and have the object slowing down, which is called negative acceleration or deceleration. And that's what we see between C and D, because it shows that the distance the object is going is starting to diminish, right? So from C to D, we see deceleration or negative acceleration. The object is slowing down. So those are your answers for the first 3. Next, we have how many seconds passed when the object was not moving. So it looked like it stopped moving at 14 seconds. 15 seconds it wasn't moving. 16, 17, 18, 19. So that was a total of 5 seconds that that object was sitting still. So you'll put 5 seconds for number 4. Number 5 says how much distance did the object cover throughout the whole journey. So starting from the beginning, this object went all the way up to about 55 meters. That was halfway in between 50 and 60, so that would be 55 meters. And then the last question says, is the object traveling towards its home or away from its home? Well, here's its home, and it's traveling away. If it was traveling towards its home, the line would be up here and it would go down. So it's actually traveling away from home. So you'll put away from home. And then you'll have all of your questions answered for the foldable. Now all we have to do is match the type of motion that's happening between each segment. So I've cut and pasted the different segments here. This is the first segment, the second segment, so on and so forth. Those are all the parts of your foldable. And here are our options. This is what can go in the boxes. Well, we already answered the question about where the object was stopped at or not moving. Remember, that's a horizontal line. So all you have to do here is I'm going to press Control-C and copy that box. And I know I'm looking for a horizontal line that's flat. And that's going to be right here from D to E. We said it was not moving. So I'm just going to take that box, paste it in, and put it there. Okay. We also answered a question already about that line with a curve, right? And we said that that was deceleration or negative acceleration. So I'm going to copy and paste that one, and let me delete that, the two that we're using so far. And let's go find that curve that showed it slowing down and flattening. So right here, remember it was C to D. So we're going to put that one in right there. Okay. Now we have to do 3 more. Now, what did we say about the curve? We said anytime you see a curve, it's going to be some form of acceleration. In this situation, it was slowing down. But in this situation, the line starts going up. So that means it's positive acceleration. So let's look. And we do have a positive acceleration here. So I'm going to grab it. And I'm going to put it right here with our first line segment of our graph. That's where that'll go. Alright, so next I have a really steep diagonal line. And then I have kind of more of a slowly rising diagonal line. Well, anytime you see a diagonal line, that's constant speed. So if it's more steep and it's going up higher, then that's going to be your fast rate of constant speed. It's climbing quickly and gaining speed quickly. But if you see just a little bit of an increase or incline in the diagonal line, it's still constant speed, but it's at a much slower rate. So we're going to take that and put that with the last line segment right here. So that's what you should get there. Now the last slide we have looks like this, and it's a race. You got distance on the y-axis, time on the x, and it's meters and seconds. You have Albert running, Bob running, and Charlie running. So they all ran a race, right? They all started right here, and this is where they all ended at. The question says which runner won the race. Well, which runner got to the 100-meter mark first? Let's look. That's Albert. So Albert got there first. He got there the quickest. So Albert is our winner of the race. Now, which runner stopped for a break? We know that on a distance time graph, if you're stopped, that means your distance isn't changing. So we see this horizontal line right here. That means this person had to stop. Maybe they needed a little breather. And follow the line. That person was Charlie. So you should have gotten that Charlie is the runner that needed a break. How long was the stop? So when he stopped, let's count how long it was. So the seconds are by 2. So this would be 2 seconds, 4 seconds, and then it doesn't go all the way, so that would be 5 seconds. So it looks like he stopped for 5 seconds, just grabbed some extra air, and then kept trucking. Or maybe he stopped to drink a little bit of water. Now it says calculate each racer's average speed. To calculate speed, it's distance over time. So we'll do Albert first. Albert's total distance was 100 meters, and the time it took him to get there was 12 seconds. So you would do 100 meters divided by 12 seconds. And I don't have a calculator on me right now, so you guys can do the math. I'll just do the problem for you. Next we have Bob. Bob went 100 meters as well, but it took him 14 seconds. So this time for his average speed, you're going to do 100 meters divided by 14 seconds. And the last racer was Charlie. Charlie got that 100 meter mark, but it took him about 15 seconds. So you'll do 100 meters divided by 15. And there you go. So that is all we did today in class. We worked through this. We answered these questions. So if you're confused or still need extra help, make sure you reach out to your teacher so we can help you out. Thanks.